Looking good.
How's that look?
Looks great.
Okay. Hello, I'm Bob Simons. I'm the author of ERDDAP. Thank you very much for tuning into this talk. ERDDAP is a data server. It's a reusable, free, and open source software program. It's been installed at more than 60 institutions in at least 10 countries, and it's on NOAA's list of recommended data servers. The ERDDAP homepage that you see here has a description of ERDDAP on the left and several ways to search for data sets of interest on the right. If I enter SST in the search box, I get a list of data sets that have some SST information, hopefully ranked so that the most relevant ones are at the top. All of the search options on that previous page lead to a list of data sets. They show you, the list shows you ways you can access the data set on the left, the title in the center, and some additional information about the data sets on the right. So if I click on one of the data links, it leads to an OpenDAP style data access form so that you can request a subset of the data. One difference is that ERDDAP in general works with the actual values. So for latitude and longitude, you don't specify an index value, you specify actual degrees north or degrees east, or the actual time for the time dimension. A unique feature of ERDDAP is that you can specify the response file type down here. There are about 20 different file types in order to get the data in the format that's easiest for you to work with. If I had clicked on one of the graph links on that list of data sets, it pulls up a Make a Graph web page so that you can create custom graphs and maps from the data. The impetus for the creation of ERDDAP was my belief that from a user's standpoint, finding data and downloading it into your favorite client software is too hard. The problems are, one, most data servers lack a search system, so it's hard to find data sets of interest. Different data servers use different request protocols, so you have to create and formulate your request differently for each of those different server types. And then the response that you get back from those different server types is different. And it's usually just one format, and it's often not the file format that you want. And as I'm sure you're aware, most data sets have time formatted in different ways. There's so many different ways to format dates and times. And then when you get the data back, it's very hard to compare the data from different data sets because of these different time formats. Finally, most data sets, in my opinion at least, have insufficient metadata. I know the creator of the data set is very familiar with the data set and all the details, but a lot of times that information doesn't make its way into the metadata. That makes it hard for users to understand the data. So ERDDAP's designed to solve these problems. Someone isn't muted. ERDDAP is designed to solve these problems and make getting data into your favorite client software much easier. So without, just look at the web and the current state of things, there are lots of different server types, and each of those is in general to work with one or a couple of clients. This is simplified, and you can debate lots of individual points, but the basic idea is that we have various communities which have evolved these servers and clients to work within their community, and they're great for their community. They solve the needs of the community. Everything's wonderful if you stay in that community. The problem is if you try and reach out to get data from some other community, and then you have to deal with this plethora of different data server types, and then the difficulty of getting the data into the different client types or getting different data files. So ERDDAP works as a middleman to be a broker, another word, buzzword, to get data from all of these different source types and get it into your favorite client software. So if we pick a client like R, a person using R can make a request to ERDDAP in ERDDAP's standard OpenDAP-like, although you can do straight OpenDAP requests as well, but OpenDAP-like requests. ERDDAP reformats that request into whatever the source server's native request format is, sends that request to the server, gets the response back in whatever format that is in from the server, for example, an OpenDAP binary response, and then ERDDAP reformats that response into whatever file type the user requested. So that then is done transparently. Acting as a middleman allows ERDDAP to improve each dataset's metadata. So when you set up the dataset in ERDDAP, you can add to or modify the existing source attributes so that you can more completely describe the dataset. Once all of that metadata has been added, ERDDAP has the information it needs to generate ISO 19115 metadata. So this is a lot like NC ISO in threads. It can generate the desired ISO XML file. ERDDAP standardizes the format of time data. So if it's representing time as a string, it comes out in the ISO 8601 format, that year dash month dash date t hour colon minute colon second. Or if it's a number, it always comes out as second since 1970-01-01, which is so-called Unix time, and which is CF compatible since it's a numeric form of the time. ERDDAP provides a unified way to search for data sets of interest and a standard way to request data from each of those data sets, and then lets you specify the file format for the response. So hopefully it solves all those problems that I identified earlier and makes life a lot easier for data providers and for users. Web applications, a web page with a form, are great for humans with a browser, but they aren't suitable for big tasks. Imagine making 1,000 requests by hand. With RESTful web services, a single request URL using a standard protocol like OpenDAP specifies an entire request. So it's easy to automate thousands of similar requests with computer programs and scripts. So it's easy to build web applications on top of web services. So that's what ERDDAP does. Everything in ERDDAP has a web application, a human-friendly web page, and which uses an underlying web service, the script-friendly service. You can use either one and hopefully do whichever is easiest or most appropriate for a given task. Most of you are familiar with threads, and threads working with gridded data and OpenDAP working with gridded data. It turns out that OpenDAP has a whole section which is suitable for tabular data as well. And so ERDDAP makes a distinction so that each data set is classified internally in ERDDAP as either a gridded data set or a tabular data set. So for gridded data sets, a RESTful URL specifies an entire request. So there's the server name, ERDDAP, the fact that it's coming through the gridded part of OpenDAP here in ERDDAP, the data set name, the file type, and then the actual request. So in this case, it's asking for the multi-dimensional variable that's called analyze SST, and then here are the dimensions. One is time, then latitude and longitude, which is the dimensions for this data set, for this variable. One thing that's I mentioned is different about ERDDAP. You can use traditional NetCDF and OpenDAP style index requests, so you can specify index numbers. But that's pretty cumbersome to use because you have to look at the dimension values and figure out which index corresponds to which latitude or longitude or time that you want. So instead, ERDDAP has this system with parentheses. Whenever you use parentheses, then instead you can specify the actual dimension value. ERDDAP will convert that into the closest actual dimension value. So here it'll find the closest time value to that time, the closest start and stop values for latitude, and the closest start and stop values for longitude. ERDDAP, I mentioned, has several response file types. There are some special file types like HTML, which brings up that web page for requesting data.graph, which is the make a graph web page. Also FTDC, ISO 1915, and the traditional OpenDAP data attribute service, I think it's service, and the data description service. So those traditional special file types. Then ERDDAP has all of these data file types, ASCII, CSV, Esri, JSON. There are actually several JSON variants now. HTML table, which shows the results in your browser in a nice table. MATLAB, NetCDF, ODD, TSV, but there are lots of others. And I keep adding new ones all the time. And there are special file types for images. So you can get a GeoTIFF, KML, PDF, PNG, and transparent PNG. Transparent PNG leaves off the legend, the axes here, things like that, and leaves off the boundaries and the land mask, and just shows you the data with the transparent image. That can be used for compositing images, so you can put different images together, but it's also used internally by WMS and KML, which return transparent PNGs that then that client software uses to make a map with multiple images composited on it. So there's gridded and tabular data. Here's the tabular request. It's very similar, but the request format is a comma-separated list of variable names, column names from the table that you want to get, and then a series of constraints, each separated by ampersand. So here it's ampersand time equals this specific value, but it could be and latitude greater than 45 and latitude less than 90 or something like that. You can specify several different types of requests. This is a straight, with one little change, OpenDAP request for what OpenDAP calls tabular data, which is sequences, but I'm going to call tabular data.
Bob, and not only can you do constraints on the coordinate variables like that, but you can also say, just give me the values where the quality flag is equal to 4 or something like that also, right?
Yes, exactly. You can constrain any of the columns, string columns, quality flag columns. There's also a regular expressions comparator here. You don't have to use equals or greater than, less than. There's also regular expression, and with regular expression, then you can do a lot of manipulations of strings, so you can get specific station IDs if they're string values or specific flag values. It's very useful for that kind of thing. You'll probably, if you're familiar with databases, relational databases, and SQL, the language that's used for requesting information from databases, you'll notice that it's very similar to a SQL request for data. So I'm told by the authors of OpenDAP that they were not really thinking of SQL at the time, so we'll just chalk it up to great minds thinking alike. But the methods used by OpenDAP are really, really similar to the methods that are used by SQL. which translates very well then if the source of the data set is a database, ERDDAP can really easily convert this OpenDAP request into a SQL request and get the data from the database, or similarly with Cassandra, which is a little more complicated, but has a SQL-like interface. Okay, and once again, there are special file types, so you can request information about the data set or see those forms related to the data set, but also request actual data or request images. ERDDAP is designed so that users don't need a plugin or a library. So I don't want to disparage plugins or libraries. They can be great, but there are some disadvantages. Users can be reluctant to install them, may not have permission to install them, have difficulty install them, and plugins often break when the application is updated. And the real problem with that is, if you're the provider of that plugin, you often don't know who all of the users are. So if there's a bug, it's often impossible to get all of the users to update a lot, just because you don't even know who they all are. It's hard even to notify them that there's a new version. So ERDDAP is a server-side solution. It runs on the server, and users access it from their favorite client software or from a program like curl or wget, which allows users to get information from a web server like ERDDAP. So ERDDAP doesn't have these problems that plugins and libraries have. Users keep using their favorite client software, and when there's a new version, the administrator of the ERDDAP updates that ERDDAP, and then poof, it's all of those changes are immediately applied to all users, and there's no hassle with getting hundreds or whatever number of users to update their client software, their plugin or library.
You might have to get the ERDDAP administrators to upgrade, though.
Yeah, that's true. That's true, and some of them look slow, but that's okay. It's okay. Anyway, the federal government, including NOAA, obviously, now has public access to research results, PAR requirements. And they say that government-funded data shall be publicly and freely discoverable via a catalog, which in practice is for NOAA, data.noaa.gov, but all of those flow into the main data.gov catalog. The data has to be understandable via metadata, accessible via a web service, although that may just be a NOAA requirement. Rich brought that up. But in any case, there is at least hints that it universally needs to be available via a web service like OpenDAP, not just downloadable files or shopping cart. The data needs to be archived in an official archive, and this needs to be done within 1 year of the data's original creation, which for most data sets then was 1 year of the original PAR requirements becoming official, which was last year or even the year before sometime. So in practice, all of this needs to be done as soon as possible. The good news is that ERDDAP can help with all of these requirements. Personally, I think PAR has been an excellent driving force because it's required data providers to do the things they should have done anyway. And for data providers, probably most of the people on this line listening into this, how does ERDDAP relate to other data servers? If you already have a data server like Threads or web pages, keep them. I'm not in any way suggesting that you get rid of what you already have. I'm just asking you to consider installing ERDDAP as an additional alternative to those current systems. I'll mention, I think users are very diverse. They have very diverse needs. And so by keeping your existing data server and web pages and then adding ERDDAP, you're going to meet, therefore, a larger number of needs of a larger number of those users. So if you don't have a data server, I hope you'll consider using ERDDAP. It's free, reusable open source software. And if you spend a day installing ERDDAP, it'll save you months or years of effort compared to making your own system. And not to offend anyone, but it probably won't be as good. And the reason is not that I'm some super duper programmer. It's that I've been able to spend 10 years making ERDDAP, and you'll have to put a lot of effort into your own system to add all of the features that I've added over the last 10 years to ERDDAP. And it hasn't been in a vacuum, of course. There have been tons of user requests, and in fact, most of the additions to ERDDAP for the last 5 years have been based on user requests. So it's a system that is designed to meet the needs of actual users with actual data sets, actual use. So it's what a deal if you get this, install it one day, and you've got a great solution that meets a lot of needs. ERDDAP lets you add off all these additional features to users that you probably don't already have. The catalog search services, OpenDAP and WMF's web services, the system that allows users to download subsets of data sets in common file formats in the user specified format. Please don't make users waste their time converting files from one format to another. Users don't need plugins or libraries, so that's a lot easier for them to work with. And users can create customizable maps and graphs, which are generated on the fly. That has a lot of uses in an immediate sense, but also for making web pages that use those graphs and maps. And ERDDAP is good for handling gridded data, as is threads, but also for tabular and in situ data. And I think for tabular and in situ data, ERDDAP is especially uniquely well suited. So you can read about ERDDAP and try it out. There's the sort of original ERDDAP server, which has the links and information about setting it up, but there's the link for downloading and installing ERDDAP. There are a couple of web pages to help data providers both install it and then add data sets to it. And there are tools that come with ERDDAP to help you generate the chunk of XML that's needed to describe each data set to get that data into ERDDAP. Thank you very much for tuning in, and if you have any questions, let's start answering questions. Thank you.
All right. Hey, thanks, Bob. I am going to, let's see, unmute everybody, or no, I guess I'm, actually Annie, can we let people unmute themselves?
Unmuted.
People should be able to unmute themselves right now. So,
okay.
Yep, feel free.
All right, so yeah, well maybe, yeah, feel free to ask a question. I guess I'm gonna ask the first question. You didn't talk too much, Bob, about what sort of files it can handle on the back end. You mentioned a data that you can use a database. What other types of files can you serve up on the back end?
Here are the.
Could you do Control+ on that, or make that a little bigger?
Yeah. How's that?
That's good.
Okay. So here are the. I'll do one more. Here are the.
There we go.
Here are the gridded dataset types. So from OpenDAP servers, there's a way of treating a tabular data set like a gridded data set, and then the reverse, treating a gridded data like a tabular data set, which is occasionally useful. You can get data from other ERDDAPs, and that's useful because then you can set up federations of ERDDAPs so you can deal with very high load situations where you have a couple of worker ERDDAPs, which are each responsible for some data set or data sets, and then a main ERDDAP, which is the public-facing ERDDAP and which users connect to. It also lets you get data from remote ERDDAP servers. So if there's an interesting data set on the Pacific Islands Fishery Science Center's ERDDAP, or the Argo ERDDAP at Ifremer or in Ireland or something like that, you can connect to that data set, and ERDDAP downloads the metadata, but when there's an actual data request, it transparently redirects the user's request to that other ERDDAP. So it looks like your ERDDAP has tons and tons of data, but actually it's getting data from these other ERDDAPs. These are different file types that ERDDAP can get data from. There's a couple of special ones. One lets you aggregate data sets side by side. So if you have a file that has one variable in it and another group of files has another different variable in it, but they're on the same grid, they're from the same data set, this allows you to aggregate them into one larger gridded data set. And then similarly, if you have data sets where there are chunks of time or individual times, you can aggregate most of these normally aggregate the time dimension, but for some unusual cases, you can do additional aggregations here. And this one makes a local copy of data from remote services, which can be handy. And then there are all these different. Yes.
Can I ask a question about that side by side? Could that be used then to say, if you had a bunch of basically tiles, say from bathymetry or some digital terrain or something, that you could put each one of those tiles in there and then use that side by side?
No. Tiles. Probably not what you're thinking. Probably not what you're thinking. This is for different variables. If there are files, a group of files with an example of this is the CMIP data. A lot of those are presented in different threads, servers, and in the actual files as a group of files that has sea surface temperature in it, and then a group of files that becomes a data set that has air pressure in it, and a group of files that becomes wind speed. And so they appear as three different data sets in threads or in FTP-like servers. But in ERDDAP, you can then merge those files as you would do an aggregation in threads to make one data set with SST, one with pressure, and one with whatever the wind speed. But you can also then use this to add those three data sets together into one data set that has both all times and all variables for that larger data set.
Okay, so I see. So they have to share the same coordinate dimensions.
Correct.
Okay.
That's what this is for. Right.
Yeah. Okay. I got it. Okay.
There are lots more types of files and sources for tabular data. It just seems like the NetCDF world has done a really good job of unifying and presenting a consistent interface for gridded data, but for tabular data, there's all kinds of legacy file formats. I say legacy, but still widely used, CSV and others, a lot of special ones. This is not the Amazon Oz, but the Automatic Weather Station. They make a custom file format. And lots of others from OpenDAP sequences, from Cassandra, from relational databases, from OBIS style service or SOS style services, lots of different options. So ERDDAP, that's part of the problem, of course, is that ERDDAP's trying to solve, is there are all these different ways of storing tabular and in situ data. ERDDAP hides all of those differences and presents each data set in a standardized way. But this is the way here where the administrator specifies the source of the data set and how it's going to be configured and appear in ERDDAP.
Yeah, great. Thank you. Does anybody else have a question that they'd like to ask Bob? And you might have to unmute yourself. Okay, well, you know, I'd just like to say, maybe just make a comment that, you know, a few years ago, I was sort of mostly, you know, trying to get people to use threads, and, you know, some people would use threads, but they found it kind of difficult, and as Bob said, it doesn't work that well for tabular data. And we were trying, in the IUSE community, we were trying to promote sensor observation service, which required people to make queries and get XML back and parse the XML and all this kind of stuff. And now in IUSE, we're pretty much, say we, I'm not really, I'm just one member of the IUSE community, but IUSE is really promoting the use of ERDDAP for tabular data, because nothing else has really been found to be useful by scientists and sort of ordinary folks who just want to get data. And once they realize that they can click around in that GUI and get that, and then get that RESTful URL that they can then use in their programs or in their scripts, as Bob mentioned, it's just they can't believe it. It's, you know, it's exactly what they've been looking for, and then they want to see everybody else's data in ERDDAP. So, and that's happening. I think it's really spreading.
Yes, ERDDAP is used by most of the IUSE projects, and it's used by most of the Coastwatch nodes, and it's used by a lot of these international organizations. The Marine Institute in Ireland makes extensive use of it. Ocean Networks in Canada uses it for accessing data from Cassandra. So it's been widely used a lot of different places, a lot of different data types.
And I guess it's worth pointing out also that it's certainly not limited. It came from oceanography, but it's by no means limited to oceanographic data, or, you know, I mean, even any kind of tabular data, really. I mean, it doesn't even have to have,
yes,
right. And it doesn't
any
have to have
tabular data.
Doesn't even have to have latitude and longitude, does it?
No, it does not. It doesn't have to have any specific column. If it does have latitude, longitude, altitude, or time, then those are named with that specific name for consistency's sake in ERDDAP, so that you can always request a subset of time or latitude and longitude by using those same variable names from any data set in ERDDAP that has those variables.
Hello, can people hear me?
Yes.
Yes.
Perfect. Lewis John McGivney from JPL here. Thanks very much for the presentation. Just quickly, say I wanted to install ERDDAP, what does the installation procedure look like?
There's an instructions here, but basically ERDDAP is a Java servlet that runs usually in Tomcat, and if you're on a Linux server, which I recommend, then it's usually using Apache as the very, very front end. So those are the only requirements. It doesn't require other software be installed or anything. So you basically just get Tomcat set up and then plop the ERDDAP.war file into Tomcat and do the setup files, and it's running.
Perfect, perfect. And the license hyperlink hasn't been clicked on here. How is the software licensed?
It's entirely open sourced and in an Apache-like license. There are a variety of a variety of libraries included and distributed with ERDDAP, and they're all here down in the credits. But I've made sure that all of them are Apache-like or MITx-like, so they're very open, very liberal licenses that allow you to, if you choose, modify the source code
Yep.
for your own uses, and you don't have to feed that back or make that public. It's the most liberal of licenses.
Brilliant. And I'm assuming there's a mailing list or there's some community forum for usage and maybe issues and things like this.
Yes. Yes. There's a Google group for ERDDAP, so you can join that.
Perfect.
And you can also email me if you have any questions.
Ideal.
Either way.
Thank you very much.
Hey, Lewis, actually one more thing too, for you maybe, I actually run our ERDDAP using a Docker container that that we have so it works nicely with Nginx also. So we just we just use the containers and it works great.
Ideal. Thank you.
I don't distribute it, but Axiom makes a Docker container with ERDDAP in it, and they always have been maintaining that. When there's a new version of ERDDAP, they'll update the Docker container. So if you do use Docker containers, that's available from Axiom.
Any other questions? Bob, do you want to? I feel like a little bit like I'm interviewing you now, but
that's all right.
Do you want to say anything about some of the questions that people ask when you start talking about ERDDAP? They say, well, how is it? How fast is it? Yeah.
Want to say it's designed to be really, really efficient and deal with large quantities of data. So for both gridded and tabular data sets, ERDDAP works with chunks of the data set at a time, so that if there's a huge request, that doesn't eat up all of the server memory at once. And also for file types where the response can be streamed, like CSV or some of the JSON formats, then ERDDAP can start responding to the request almost right away, instantly, because it doesn't have to generate the whole response and then send it. Now that isn't true for some file types where that's just not possible, like NetCDF. For NetCDF, the entire file has to be created before that it can start to be sent. So ERDDAP has to do that. But for these other types, ERDDAP starts responding very quickly, and as I mentioned, deals with the data in chunks so that it can respond in a streaming manner.
And did you mention that it caches like coordinate data and stuff, so it can do that indexing really quickly?
Yes, thanks. So all of the metadata and all of the dimension data for all data sets is cached in memory. So whenever you do a request, for like searching through it, the search requests are the information that is searched is cached and in memory, so it can do that search super fast. And if you do the requests for example, for one of these pages, it will already have all of this information in memory so that it can generate these pages very, very quickly. You'll see all these pages pop up very fast. And I'm at home right now, just so you know. I'm not at ERD, so these requests are actually going up to Seattle, which is where the outlet for NOAA on the West Coast is to the internet. So this request has to go up to Seattle and then go back down to Santa Cruz, where this ERDDAP server is. So I'm not just showing you a local request. I'm actually doing these requests on the fly, and you're seeing, I don't know how fast the response of GoToMeeting is, but ERDDAP can do all of these things really, really fast, making the images, showing you the web pages, doing searches. It's all designed for being super fast.
And actually, you can't really see the URL that easily there, but I was just going to point out again, like you said, that everything is up there on the URL and those, everything that when you click around, it's right there. You can see it. And if you change that time value in the URL, if you just change it from August 8th to August, to 7th, right? You could just change the URL and execute it again. You just reload your page and you see a different stuff, right? So
and so if I do that, there's a request for data, and there's the HTML table showing the response, and that's the URL which was sent to ERDDAP, to the RESTful service. So if I requested for the previous day, just by changing that then there's the response for that. So
this is right.
So again, that's.
Go ahead.
Go ahead, Ray.
I was just going to add, if people worry about scalability, the ERDDAP server that Bob's hitting right now gets between 500,000 and 1 million requests a day. To give you an idea of how scalable it is.
It's often 10 requests a second, because we have a large number of scripts which various people use to request little bits of data from ERDDAP. And the most common script is one that is used to get environmental data which is related to an animal's track. So they put a tag on the back of an animal. The animal swims around in the ocean for a long time. They recover the tag and the information that's in it. All it has is location and time information, or it can be derived from that. And so people run these scripts to get the related sea surface temperature and chlorophyll and other information from different data sets in ERDDAP. And they do that, then the script runs through for a given time, given latitude and longitude, it gets the related sea surface temperature data. Sorry, that's
Bob, could you just
there.
go? Oh, sorry. Could you just go back?
Yeah.
No, go ahead. Sorry, I didn't want to interrupt you.
So those scripts, they often have 1,000 or 10,000 time and location points, and so that they just run tick, 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 making requests, and that's why we often get huge numbers of requests. But ERDDAP's designed to handle those requests super fast, just as often as it can, or as well as it can. So we often see really high volumes of usage, and ERDDAP stands up to that high level of usage.
I was just wondering, Bob, if you could go back and just pick a tabular data set and just something with that has temperature as a function of time, or something something simple that yeah.
There's a good example with tabular data sets. If there's a limited list of options for one of the variables, like here for the NDBC has about 1,000 buoys. Here's the list of buoys. I can pick one of them and request the data. I don't know if this one has really recent data, but let's see. There it is. But I can request just specific variables. I should also mention, once we're doing things, there are a lot of filters in ERDDAP. So if you want a list of stations, you can just say, I want the stations and their latitude and longitude, since these are fixed stations, and I just want the distinct values, and it'll generate that list of stations for you with latitude and longitude.
And again, that's everything is, yeah, sorry.
On the fly.
And
on the fly, and there are a lot of other, and everything's RESTful. It just becomes part of the URL. So here with distinct, then distinct is added on as at the end of the request. So those filters are particularly useful. You can order by, for example, station, and then get the maximum. So if you order by station and then get the maximum, or by station and then by time, and then get the maximum water temperature here. Water temperature, and we'll just do it for a limited range time. So if we look at all the data since the beginning of this month for all stations, so there are 1,000 NDBC stations, and we're going to sort it by station, and then by time, and then by water temperature. See how long that takes. A while, because it has to open 1,000 files. Oh, this is a slow rate too, but anyway, it'll work. It'll do it.
Bob, while we're waiting for that, when you mentioned before about the streaming, could you actually stream data from a real-time sensor then, sort of like through ERDDAP to like a browser? Like,
right now, ERDDAP is read-only. So if you have a system which has a sensor and connected to the internet, and it can push data to your system, and I recommend netcdf3 files with an unlimited dimension, then you can make a tabular data file with the data from that sensor, and it will be immediately accessible. There, it's read 1,000 files, and there are all the responses. Anyway, so it works well with near real-time data if you have the system to get that data quickly, and it's used for at least one of the DART buoys, the ones that look out for tsunami waves in the open ocean. So it's used for at least one of those, and they wanted sub-second, less than a second response times, and so ERDDAP's able to do that. But coming in ERDDAP is a system where ERDDAP will allow a data provider to push data into ERDDAP. It will be stored in, again, netcdf3 files with unlimited dimensions as a log, and then immediately be available. So again, the goal is for the system to get new data. It's created from the source, have it accessible within ERDDAP in less than a second. So that's pushing it to the server, making the change to the file, and then having it be immediately detectable by ERDDAP and available for users to request. So all of those changes should be accessible then to the user in less than a second. We talked about threads before. One of the big advantages of ERDDAP over threads, even for gridded data, is that ERDDAP has a system for detecting changes to the file system. It uses the native system, just as if you had gone into Finder on a Mac or Windows Explorer in Windows. Just as this system stays updated, operating systems have a system to manage that. So ERDDAP links into that system, and if a given data file is updated, ERDDAP will be able to detect that in less than a second, and makes that data accessible. So in threads, it's hard to tell threads to look for new files or look for changed files, but in ERDDAP, that can just be done automatically and detected in less than a second. And so that the data sets are always perfectly up to date and reflecting the data that's in the files that's accessible to ERDDAP.
Yeah, that's a great feature actually. And another thing that ERDDAP has that I don't think you mentioned is it's very stable. In our thread servers, we often have to reboot them or, refresh them because something has gone wrong. And ERDDAP, you can just leave it running. You don't need to just restart stuff when new data sets arrive or anything. It just keeps on running.
Right. When there are changes to a data set or to the metadata, then ERDDAP will automatically detect and deal with those changes. If you add data sets or remove data sets, ERDDAP again will just deal with that while it's running. You don't have to restart ERDDAP. So ideally, and in practice, most of the time in ERD, the only time we restart ERDDAP is when there's a new version of ERDDAP every couple of months, or when we need to install a new version of Java or Tomcat, which are the underlying software packages that it uses. So ideally, you don't have to restart it ever, except for those big changes, and it deals with all of the changes that you need to make while you're administering it.
I'm going to ask again if anybody else wants to ask a question. And so we got 7 minutes left. I just want to ask one more question that I know I get a lot, which is this ERDDAP, and I've heard your response to this, Bob, but the folks who are on the call probably haven't. How do you respond when somebody says, Jesus, it looks great, but Bob Simons is the only guy who understands this stuff, and what if he decides to go work for Facebook or wins the lottery? What's going to happen to us?
Well, as I've said before, I said a couple things. One is I have enough money to retire now. I could retire now, but I'm not. And I had the opportunity, at least possible opportunity, to go work for Google a while ago, and I didn't. I'm committed to this, and this is something that I feel passionately about and have worked on for 10 years and wish to continue to work on for the rest of my career. I'm not looking to change. So I'm committed to it, and I have a full-time, hard money position, and I have the full support of Roy Mendelson, my boss, who inspired the creation of ERDDAP, and then has been very, very good about giving me time to work on ERDDAP and making this the focus of my work. So there's my commitment of it to it. There's also the most important thing, which is that it's an open source license, Apache-like or MITx-like, which is the most liberal of licenses. That's the best guarantee anyone ever can give you. So Google or Apple, if they don't have 1 million users or whatever for a given piece of software, they might shut it down, and they just shut it down and give you a few months notice, and then they stop working on it. And if it's proprietary software from Google or something like that, well, that's it. That's the end. You have to find some other alternative. ERDDAP is open source. You can get the source code right now from GitHub, and it's all commented. So if anything were to happen to me, then someone could pick it up, read the documentation that's in there in the source code files, and continue the work. Having said all that, I welcome other programmers to get involved. Two people have already come forward and contributed code to ERDDAP. There's a programmer's guide. And there's one especially big, important guy, which I won't give you details because it's not finished yet, but I'm hoping that there will be another major contributor soon, who will be working on a lot of big projects that I haven't had time to do, but have wanted to do for a long time, and that are of interest to him and his group. So I certainly welcome that. I think it would be, I'd actually prefer a very distributed development group. So I welcome other programmers to join in and contribute code to ERDDAP. Here's the guide to helping you get started. So I hope that will happen. I think it's a good sign that ERDDAP was and has been created by one programmer working about 3/4 time on ERDDAP. I think that's a good sign. I heard a talk by a leader of a group who had 10 developers and himself. And so they had a yearly budget of more than $1 million. It was all soft money. That meant that each year they were struggling to find funds, and they just couldn't imagine getting rid of any of those developers because each one was so essential, and each one did some part of the development work. So they had this huge need for a huge group to be working on it and a huge amount of money each year. ERDDAP is not like that. It's very modular and organized, and if one person has done all of this in 10 years, then certainly one person replacing me or working with me could continue this work. I think that's a good thing in one sense, that it's just one developer.
Right. So and as it's spreading into major institutions that then begin to rely on ERDDAP, you would hope that some of them would
yes, think
about contributing some of their development time to helping to maintain or to add extra features and not just rely on you.
Yeah, and there's that. It's the classic open source idea where different people in different organizations with different requests can then work on fulfilling that request. If you want some ERDDAP to write out some other file format, well, you could write that writer, and I'm be glad to help you. Or if you want ERDDAP to be able to read data from some additional file type, then you can add that. And in fact, that was one of the things that someone did. There was a guy in France who was ironically working with a custom legacy file format from NOAA, and he wanted to read the data from those files, and ERDDAP did not have the ability to do that. So he added the code to do that, and I merged that back into the main ERDDAP distribution. So yes,
cool.
that can be done, and that'd be a great system if we could do more of it.
All right, Bob. Well, thank you so much for that presentation and for all the additional information about ERDDAP. You guys should definitely check it out. It's pretty amazing for any kind of tabular data, as you heard. And so thanks, and join us again next month, where we're going to hear about Jupyter Hub from Brian Granger. So thanks again, everybody, and see you next month. Thanks,
Thank
Bob.
you. Bye.
Unmuted.